In the previous video, we saw that that neural networks can help us solve many complex problems, or they can help us classify complex data with high accuracy. The simplest neural network is a perceptron. So this is a neural network in which the neurons in the input layer are directly connected to the neurons in the output layer. So in the example that we have here, the inputs are F1, F2, and F3, and the output is here. The way this neural network works is that so each input is connected to the output with some given weight, and then in the output node we compute the sum of these of the product of each input and weight, which in the end gives us the final result that we're looking for. Specifically, here we would multiply F1 by the weight 1, which connects this input F1 to the output. Then we multiply F2 by this weight 2, which connects F2 to the output, and then we'll multiply this F3 times this third weight, which connects F3 to the output. In the output, these weights or these products are added together, and then we transform this using what's called an activation function. So the activation function takes this value that we just explained and computed, and then transforms it, and this will give us the output signal of the neuron that this sum arrives in. So in this case, in the case of the perceptron, we use a linear activation function. That is, if the result that we get when we compute this here is positive, then we output +1, and if the result of this here is negative, we output -1. In larger neural networks, this doesn't always have to be this type of threshold function. It can also be any function. We'll look at that later. So how do we train the perceptron, or how do we find these weights? Initially, we set all weights to 0. Then we take each training instance from the training set. So we take one training instance, and then we classify it using the current weights. We check to see if the output that we get is correct. If it is, then we don't need to change anything. We just take the next training sample. However, if this is wrong, we adjust the weights to get closer to the correct answer. So we look at the output, and we see that it's wrong. We change the weights so that the answer would be correct. And then we again take the next training instance. We need to keep repeating this until there are no updates during one pass of all training instances. So we stop this training when we do one pass for the entire training set, and then we get no weight updates for any of them.